Hello everyone, my name is Chris Jones and I'm one of the tutors on the IBS Americas course in London, and I teach strategic innovation. One of the topics we cover is generative AI, which I'm going to talk a little bit about now. However, if you want more information on this, or if you want to come and study in person, or if you want a certificate, then check out all the links down below. So let's get started. So AI is so hot right now. It suddenly became a big talking point. It's in the news, mostly because of two big bits of software. That is chatgpt and Stability Diffusion and Midjourney, which can both generate text and images between them. It's not all that AI is doing though. Okay? AI can also generate pictures of cats. This is a website called thiscatdoesnotexist.com. It can also drive cars. Tesla has actually developed two neural chips to go in its cars to allow it to learn to drive using cameras all around the outside of the car. So AI seems to be having somewhat of a renaissance. So I thought it might be interesting to talk about how it works and how we've got to where we are, maybe some of the problems with it. So AI is a very big field. It encompasses lots of different things, from self-driving cars to autopilot in planes to the prediction algorithm that works on Facebook's advertising. However, we're going to look particularly at machine learning. Okay, why? Well, because machine learning is based on a learning computer. It's based on a neural net. So is a neural net proper AI? Well, according to the T101, his CPU is a neural net, so I guess it is. Anyway, how does a neural net work? Well, we don't program a neural net, we train it. And that's something that takes a little bit of time to understand. We don't set instructions out for a neural net, we build the neural net, and then we train it to learn the task that we need it to do. So how does that work? Well, it all starts with this, a perceptron. Okay, there's no real thing here, this is just a software element called a perceptron, but it has outputs and inputs. So it's got two inputs, X and Y, that have some kind of weighting, and an output. Now you can have multiple perceptrons tied together, so usually you have lots of outputs tied into lots of perceptrons, and they input and output different things. But let's focus on this super simple perceptron, just to understand how it works. So let's give it a bit of context first. Rather than having nothing there, let's have a stock market perceptron. This sounds like a fairly useful perceptron to have. We'll give it information about companies, and then it'll tell us whether we should invest or not. A simple 1 or a 0. So let's say we give it the average revenue and the age of the company. And then we have some kind of trigger function, which we're not going to go into. It's just a mathematical equation. And then it'll output yes or no, should I invest or not? And that's it. Okay, very, very simple. But how do we decide what's more important, average revenue or age of the company? We might decide that average revenue is more important than the age of the company, okay? Because obviously if you're making money now, that's more important than if you made money over a long period of time. So, in fact, if you think about a company like Kodak, it was very popular for 103 years and then it went bust. So maybe age isn't important at all. Okay? Think about the unicorns like Airbnb and Uber. They had massive, massive average revenues and they were very, very young. But then again, you get some companies like WeWork that purport to be unicorns, but actually they're donkeys with carrots stapled to their heads. So maybe age is a little bit more important than that, okay? So maybe we can say some value to the age, quite a lot of value to the revenue, but we're still making a guess. We still don't really know. Really, we have no idea what the value of these two things should be. So, what do we do? Well, let me welcome you to Perceptron Park. And in Perceptron Park, we evolve better and better perceptrons. And this is how we do it. To start off with, we have exactly the same perceptron, but all the weights have been randomized. So you can see all over this slide, the numbers are completely random. And then what we do is we feed these perceptrons old stock market data. So we can give it data from 1 year, and then we let the perceptrons guess which stocks they should invest in. And then we fast forward the data by a year and see which stocks did the best. And it means we can train the network by saying, okay, well, you didn't make any money on the fake data, you didn't make any money, you didn't make any money, you didn't make any money, you made the most money, so that one surviving perceptron gets to breed. So we take that one surviving perceptron, the one that did the best, and we make lots and lots of copies. And then we just tweak each one. Not very much, just 1 or 2, up or down. Okay, just a little tiny change. In the same way that all of these are all similar to their parent, in the same way that most people are similar but not identical to their parents. Okay, and it's the same idea. We want a little bit of change, but not too much. And we do this over and over and over again, until eventually you get to the point where perceptrons and neural networks and AI systems in general now run about 80% of the stock market. Okay, whereas a single stock trader can maybe see one event bar in a second, a robot can see thousands of transactions going on every few nanoseconds. So massive, massive shift to AI in the stock market. That's why we get such massive crashes now. So what about deep learning? Deep learning is part of machine learning, but it's a subset. So let's talk about that a little bit. What's the difference? Well, going back to our basic perceptron, most people will have worked out that there's more important things than just average revenue and the age of the company. Okay? Maybe average profit is the most important, or maybe the tweets of the CEO are very important, or maybe the number of employees. Lots and lots of different things that say whether you should or shouldn't invest in a company. And some of these are linked. The average profit and the age of the company leads to some kind of expectation of profit. Because if you have an average profit over more years, that's more of an average. So how do we tie all these together? It gets very, very complicated. So instead of working out exactly which ones to connect together, we link everything. Link all the things. Link every value you can. Because once you've got everything linked, you end up with a network that can solve a problem like this. This is the MNIST dataset. These are numbers written and labeled. And a network like this can tell you exactly which number is which. How? By learning which number corresponds to a 1 and which number corresponds to a 2. Over time, many of these networks working together can take all those data sets and say, okay, this number over here, these pixels seem to be important, and therefore it's a 0. And it draws big 3D diagrams like this saying, these numbers over here are all 6s, these numbers over here are all 0s, these numbers here are all 2s. Now you might think, Chris went really fast then, I don't quite understand what's going on. But the reason why is because we don't really know what's going on, okay? And I'll come back to that later. So, what about ChatGPT though, okay? And what about Stable Diffusion? How can a perceptron do stuff like that? Okay, the stock market example works quite well. But again, how does a perceptron do something like that? Well, for the text generation, what we do is we have inputs, which are words, and we have outputs, which are other words. Technically, they're called tokens. But what we can do is we can take our words, we can feed them into the network, connect them to everything else, connect every word to every other word, and then connect that to more nodes and more nodes and more nodes and more nodes, and eventually the network will take an input of the cat sat on the, and it will be able to correctly predict the next word, Matt. And that's all ChatGPT does. It just predicts the next word in a sentence. Okay? So have you ever seen predictive text? Exactly the same thing. ChatGPT just does it on a massively bigger scale. Okay? So the way it works is you take all the data in the world and you feed it just the first half. The cat sat on the. And you don't give it the answer. It's like the old stock market data. And then it runs through this network and says, Matt. And then you show it the answer. The cat sat on the mat. Correct. You guessed correctly. And by doing that, it can learn on its own, just from masses of text, how to predict the next word for any given sentence. And then it can feed that sentence back into itself and predict the next sentence, and the next sentence, and the next sentence. And that's all it's doing over and over again. It's just predicting what continues the text that you've entered. The second stage is you then get users working on computers to ask it questions. So user says, can you tell me a joke? And the AI says, where does the king keep his armies? In his sleeveys. That's a fair joke. So the user says, correct. Okay? So that allows the AI again to train itself, not just to be able to predict words, but also to predict words in a way that answers questions, in a way that sounds like a conversation, because it's practiced having a conversation with these people. What about image generation? What about if we want to generate an image like this amazing image of the Terminator? Well, we still use perceptrons. Imagine we had a blurry image like this. Well, we could easily write perceptrons, take some of the data from this image, say like that little bit around the eye, and we can turn it into pixel data, and then we can put the pixels into a neural net and ask it to predict what pixels need to change to make the image clear. So we can say, okay, given this image, predict what the pixels should be like to make this image nice and clear. That's a fairly standard thing. We've had that for a while. Cameras have been able to sharpen images for a while. This is kind of what the CSI Enhance feature does, although that isn't a real thing. Okay? But what about if it's a really blurry image? Well, how about we give it a fighting chance? We say, okay, here's a really blurry image, but we're also going to give you a text prompt that explains what the image is. And the system can go, okay, cool. With these pixels and this text prompt, I can work out that this should look like this. That sounds great. But then we play a trick on the AI. Then we take the blurry image and we replace it with random noise, just random colored dots. But we still tell it that it's a photo of a robot skull. So this poor AI that's learned to unblur images is now trying to find a photograph of a robot skull in this random noise. And it does that by continually tweaking the colors to try and get something that matches what it expects with a photo of a robot skull. So it doesn't come up with exactly the same image, but it comes up with an image. Okay, it's come up with these two images. One of a photo with a robot skull with red eyes, and this one's got no red eyes, but it's still a robot skull with teeth. So it's kind of got there, okay, because it's kind of invented it itself. So this is how these generative image systems work. Okay, so these are the steps. And when I said you might not have understood exactly how it works, hold on, because this is where we explain it, or rather don't. So original AI, we write the instructions, the machine follows the instructions, we get an output. Machine learning, we extract features that we're interested in, the average revenue, the average profit, etc., and then the machine learns how to weight those things to come up with an output. Deep learning, we're no longer extracting particular features, we're just giving all the data to the AI and we're letting it learn those connections itself. It works out what's important and what's not important. Have you noticed there's no human in the loop here? Okay, we're just giving pure data to a big neural network and it outputs whatever we want it to output. Okay? This is how ChatGPT works, it's how Stable Diffusion works, it's how most of the large deep learning systems work. And the problem with that is that the reason AI got really good is because we gave up understanding how it works. By giving up understanding how it works, by giving up understanding exactly what the important pieces of input are, the AI was able to train itself on its own millions and millions of times a second and get really, really clever. But we now no longer know exactly what's going on in its head. We've kind of given up on that. It's too complex. It's just millions and millions of numbers. Like we can look at every single neuron inside ChatGPT and still can't understand why it makes some of the mistakes it makes. So what are our assumptions so far? Well, our assumption so far is that the AI actually works. What about when it turns evil? Well, as we know from sci-fi movies, AI eventually turns evil. It's almost as sure as anything else. So, are we really going to be overtaken by robots that look like the Terminator? Well, probably and hopefully not. But that doesn't mean there aren't any issues with AI. So what are some real issues with AI? Okay. Well, there was a great paper called Concrete Problems in AI Safety, which came out in 2016 by these three companies, all working together. And they came up with these 5 areas in particular. Now, there are probably more that have been developed since, but these are a really good starting point. So let's look at how some of these affect us in real life situations. So one AI that caused a lot of hassle in the news was the Facebook advertising AI. Now, the Facebook advertising AI had a side effect problem. Okay? It did what it was told to do, but to do that, it did something else as well that it wasn't supposed to do. It's a side effect, something you wouldn't have expected. So what the Facebook AI is supposed to do is it's supposed to sell adverts to Facebook users. And it gets points, it gets allowed to survive in that Perceptron Park environment when people click on the adverts. So if you see a picture of someone like this on Facebook, then Facebook's algorithm goes, aha, I think you'll probably be a Trump voter. I'll give you the Trump advert. If you see someone like this, you go, oh, probably a Bernie voter. Someone like this, probably a Bernie or a Hillary voter. Someone like this, oh wait, this guy could vote for anybody. He's just a regular guy. He could be voting for John Kasich, so centre-right, Hillary, centre-left, Bernie, Trump. We just don't know. Okay, he's not very predictable. Same with this lady. Okay, she could be sort of pro-business owner. She could be on John Kasich's pro-business policies. She might be a Trump voter. She might be a Hillary voter. She might be a Bernie voter. We don't know. There's not enough in Facebook's information to pick what she'll click on. So the Facebook robot gets very upset. okay? Because it's only getting points if it gives people adverts that they click on. And if they're not very predictable, it can't do that. So, without meaning to, without anybody programming it, it gradually works out that if it starts giving guys like this news stories from one end of the political spectrum, it can gradually shift people from this to this. And then they're very predictable, and you can give them adverts for Trump and adverts for right-wing policies, and they'll click on them. So without trying to turn up the world upside down, Facebook's algorithm just gradually polarized people. And not just to the right, but also to the left. If you're slightly to the left, then you'll see more and more stories that push you further and further to the left, and then eventually you become very predictable and start voting for people on the far left. Or not just voting, but buying stuff from companies who focus on the far left, etc. So all it wanted to do was sell adverts. But to do that, it polarized the population of Facebook, which is probably, I think, the third or fourth largest population online. Okay. What about things like ChatGPT and Stable Diffusion? Well, ChatGPT has a problem with reward hacking. Okay. So reward hacking is, from Charles Goodhart, when a measure becomes a target, it ceases to be a good measure. So when the system is trying not to actually do what you want it to do, but to win based on a set of rules, then it starts to hack the system. So how does it hack the system? Well, remember these guys that have to give a yes or a no to ChatGPT to help it learn how to answer questions and how to interact with humans? Well, this is what the AI kind of developed as a side effect, as a hack around this system. So say someone asks, where is Paddington Bear from? Now, Paddington Bear is from Peru. Paddington Bear is from deepest Peru. This is in the books, it's absolutely canon. So, Paddington Bear is from Peru. Now, the AI doesn't know that Paddington Bear is from Peru. I'm anthropomorphizing a little bit. The AI obviously doesn't look like this, but it has no idea. However, it wants to get that green thumbs up. It wants to get the points. So if it says, I don't know, then it's learnt that saying, I don't know the answer to that, I've got no clue, will 100% get it a red thumbs down. It will lose points, and then it won't be able to, that version of the network won't propagate into the rest of the perceptron park environment. So if it says I don't know, it knows it's going to get 0 points. But if it has a guess, then it only loses if the person who's talking to it knows the right answer. So it's much easier for it to go, Brazil? I don't know, maybe. Okay, it kind of has a guess. And the reason it has a guess is because if the person who's testing it doesn't know where Paddington Bear is from, there's a 50-50 chance they'll say, yeah, Brazil's probably right, and give them the points. So what we've done is we've trained ChatGPT to be a fake it till you make it blagger. As a result, it's very confident with everything it says, but it doesn't always say things that are correct. If you ask it for sources, it will generally make things up. It will make up journals, it will make up authors, it will make up historical facts to match whatever you've asked for. A particularly high profile case was a legal case where it created an entire precedent case which never happened. And a lawyer tried to fight on this precedent, which was from a case that didn't actually exist. Stable Diffusion has this problem where it can't robustly shift in time. So the problem with things like this is, remember, they've been given images and prompts from data from the past. So whenever it was shown a picture of a robot skull, that was a picture of a robot skull from the 1980s. I'm sure robot skulls have come on along since then. So as a result, anything that happens in that past data gets imprinted and coded into the network while it's learning. As a result, if you ask something like, yeah, this is DALL-E, to generate pictures of CEOs with a pot plant, well, they're all middle-aged white guys, except this middle-aged white guy with long hair and lipstick, which is still a middle-aged white guy. Or if you ask it to generate cleaners, it picks out races and minorities that are most likely to be cleaners in pictures that it has in its database. Another one I tried was, give me a picture of criminals playing tennis, and apparently the stereotype of old ladies playing tennis beat out any others, so we've got these old lady criminals playing tennis, which is quite an interesting one. Okay? But these problems are real problems that we have to deal with AI. Any stereotype that we've built into our past data is now going to be locked in to any AI tools that we use in the future. So that's a real issue. Whether it causes robots to take over the world or not, I'll leave to the future people to decide. But it's still an issue that we need to consider. Okay? If we're relying on ChatGPT to tell us things that are important, like say, I've got a pain in my chest, what should I do? We don't want an AI that's learnt to lie to appear more competent than it is. We need to work out what the limitations of these systems are before we start leaning into them and trusting them with things. Same with the stock market. We don't want stock market AIs that can crash markets overnight because they all get a bit scared about a news headline. So AI, very, very complicated. Hopefully this explains a little bit more about how it works under the hood and takes away some of the magic, and also raises probably as many questions as it answers. But that's it for now. If you'd like more on these kind of topics and more about strategic innovation, strategic management, and various other things that we cover, check out all the links in the description below where you can get a certificate. You can also come and join us in person and have classes here in London. All the best, and thank you very much for listening.